In this video, we're going to talk about how we can rewrite an equation written in standard form into intercept form. So while rewriting an equation from standard form into intercept form might seem like an impossible task, we actually already have the skill set to do this. So if you kind of ignore this y for a minute and pretend there's a 0 here, what you'll notice is we have something times something times something. I just wrote is equal to 0, but we have something times something times something is equal to, in this case, 0, but now in this function it's equal to y. What this really is, this intercept form is really factored form. So when we spent all that time learning how to write something into factored form, we were actually learning how to write intercept form of a quadratic function. We just didn't know it at the time. So now what we're going to do is we're going to take our knowledge of factoring and we're going to rewrite this quadratic function here from standard form into intercept form. So if we look here, what I notice is we have a trinomial. And so I know that we have 4 strategies for factoring. We have the GCF method, we have the ABC method, we have those perfect squares, and we have factoring by grouping. Those are our 4 strategies. And if I start to look here, what I notice is that GCF isn't going to help me. There are no perfect squares and there aren't 4 terms. So if I want to put this into factored form, I need to use the ABC method. So I start off by identifying my A, B, and C values, which in this case I can see are 2, -11, and 12. And if I'm going to use the ABC method, I need 2 numbers that multiply to A times C, which is 24, and add to B, which is -11. So if I start thinking of numbers that multiply to 24 and add to -11, I end up with -8 and 3. So I can rewrite this equation here as 2x squared minus 8x minus 3x plus 12. And then in the ABC method, we then group in pairs. So I know that the greatest common factor of those first 2 is 2x. So I factor out a 2x here to get x minus 4. I then want the parenthesis pieces to match, so I factor out a -3 here to also get x minus 4. Because those parenthesis pieces match, I can group the 2 items factored out in front together. So I have y equals 2x minus 3 times x minus 4. Now this isn't perfect intercept form. If it was perfect intercept form, we would actually factor out that 2 in front. So here, if we wanted to go a little bit further, this right now is an answer that I will accept. But if you really want it to have your A value out in front, you just focus on this piece right here. And notice we want to factor a 2 out of that. So if I were to factor a 2 out of that, that would become x minus 1.5. And then it would be still the x minus 4. So if you wanted to take it that one step further and get it all the way to with an A value, you just focus on anything that doesn't have a straight x in the front, and you can factor that out a little bit further. But what we have here in orange would be fine, just that understanding that you can take what we have from standard form and convert it into intercept form using our factoring skill. So now let's take the time to rewrite the problems that we see here on the screen. So remember, we have 4 strategies for factoring. We have GCF, ABC, perfect squares, and factoring by grouping. So we have to decide which one is the most appropriate for each problem. Well, if I look here at this first one, I notice that both items contain an x, and both are divisible by 6. So I'm already thinking that GCF is the most appropriate strategy here. So here I factor out a 6x, so I end up with y is equal to 6x times x minus 4, which looks a lot like intercept form, but that there's kind of this weird x in here. But what's really happening with that particular x is that's really an x minus 0. That's what that really is. So you can write that in there as x minus 0, or you can just write it in there as 6x. It doesn't matter. Either one of these answers would be okay, but here we can see that we have our intercept form. We have this set up as a multiplication problem of items equal to y. Then if I look at my second example here, what I notice is this is a 1x squared and a 16. So I can see that this is a perfect squares 1. And I can see here I can automatically split it up into 2 right off the bat. So I would have the square root of x squared is just x. The square root of 16 is 4. So I put x's in the front, 4's in the back, and then because there's no middle term here, I know that b is really equal to 0. So there's some canceling going on, which means that I have one positive and one negative 4. And there is my factored form. I have something times something is equal to y. And then final example here, I notice that this doesn't contain perfect squares, can't do greatest common factor or grouping. So this is another A, B, C problem. So I start off with A is equal to 1, B is equal to negative 4, and C is equal to a negative 32. So I need two numbers that multiply to A times C, which is negative 32, and add to B, which is negative 4. And if I start thinking through the factors of negative 32 and determining what they add to, I find that negative 8, 4 will multiply to negative 32, but add to negative 4. So we have y equals x squared minus 8x plus 4x minus 32. So I now look for the greatest common factor in pairs. In the first one, that becomes x. So we have y is equal to x times x minus 8. In the second pair, we can factor out a 4, and that will make the parenthesis parts match with x minus 8. Because they match, we can group x and 4 together. So we get x plus 4 times x minus 8, and that's equal to y. So again, we see we have intercept form because we have something times something is equal to y. So we can use all of our old factoring strategies here to help us rewrite standard form equations into intercept form. And then that can help us to find our x-intercepts of a particular function that is written in standard form.